Let's begin with question number 1. It says All India Radio Services of Vivid Bharati is transmitted on 219-meter band. What is the transmission frequency in hertz? So frequency is known to us. Frequency is C upon lambda, where lambda is given in the question. That becomes 3 into 10 to the power 8 upon wavelength is 219. This was in meter per second. These many meter. So this comes out to be 1.369 into 10 to the power 6 per second, or these many hertz. Let's move to question number 2. Certain sunglasses having small crystals of silver chloride, incorporated in the lenses on exposure to light of appropriate wavelength turns to gray color to reduce the glare of the reaction. A reaction has been given to you. So one molecule of AgCl, if we see the reaction, in the presence of light, it is giving silver plus chlorine. If the heat of the reaction for the decomposition of silver chloride is 248 kilojoule per mole, so E is given to you as 248 kilojoule per mole, or we can also write it as 248 into 10 to the power 3 joules per mole. This is given to you for 1 mole, and 1 mole is equal to how much? 1 mole is 6.023 into 10 to the power 23 molecules. So for 1 molecule of silver chloride, let's calculate the energy. What will it be? So that becomes 248. E will be equal to 248. These were given for 1 mole. So 248 into 10 to the power 3 joule per mole upon 6.023 into 10 to the power 23 molecules per mole, right? So this gives us 4.12 into 10 to the power minus 19 joule per molecule. So each molecule is having an energy of 4.12 into 10 to the power minus 19 joules. Corresponding to this, they are asking what maximum wavelength is needed to induce the desired process. So we know E equal to hc upon lambda, whereby lambda becomes hc upon E. This is 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 upon, what was the energy? 4.12 into 10 to the power minus 19. If you solve it, it comes out to be 4.82 into 10 to the power minus 7 meter. These many meter is the wavelength. Let's move to question number 3. It says if Einstein E is the total energy absorbed by 1 mole of substance and that each molecule absorbs 1 quantum of energy, then calculate the value of E in terms of lambda in centimeter. Okay, so let's first find out the energy of each molecule, which should be equal to, because each molecule is absorbing 1 quantum of energy, equal to hc upon lambda. That is h into c, we know, is 1.988 into 10 to the power minus 25 joule meter. This upon lambda. Let's convert it into centimeter. It becomes 1.988 into 10 to the power minus 23 joule centimeter upon lambda. So this is the energy of 1 molecule. The question is asking us for energy, total energy of 1 mole of molecules. So that is simply energy of 1 molecule multiplied by Avogadro number. And that comes out to be 1.988 into 10 to the power minus 23 joule centimeter into 6.023 into 10 to the power 23 upon lambda. If you solve this, this comes out to be 11.969 joule centimeter per mole upon lambda. And if we convert joule into erg, we know 1 joule is equal to 10 to the power 7 erg. So we can write it as 1.1968 into 10 to the power 8 erg centimeter per mole upon lambda. This should be the answer. Let's come to question number 4. Okay. Okay, question 4 and 5 both are the same. Let's move to 5 directly. The question says calculate the energy involved when 1 mole of substance absorbs red light of frequency 4 into 10 to the power 14 per second, given that one molecule absorbs 1 quantum. Okay. So we know that energy is equal to h nu, correct? That becomes h is 6.626 into 10 to the power minus 34 joule per second, and nu is given to us as 4 into 10 to the power 14 per second, right? So this comes out to be, if we multiply that, then this will be 2.65 into 10 to the power minus 19, these many joules. And the question says that we have to find the energy involved when 1 mole of substance absorbs energy. Okay, so for 1 mole it will be, 1 mole is Avogadro number, so simply multiply this by Avogadro number, that is 2.65 into 10 to the power minus 19 into 6.023 into 10 to the power 23. That comes out to be 15.95 into 10 to the power 4 joule, or more appropriately we can write it as 1.595 into 10 to the power 5 joule. This is the answer. Okay. Let's move to the next question, that is question number 6, which says uh, calculate the number of quanta of radiation of frequency 4.67 into 10 to the power 13 per second that must be absorbed to melt 10 gram ice. Okay, the energy required to melt 1 gram ice is 33 joule. Let's begin with the question. So we know that energy required to melt 1 gram ice is 33 joule, means energy required to melt 10 gram ice will be 330 joule, correct? So this is the amount of energy that is required. Now it is asking calculate number of quanta of radiation of frequency this much. So let's find out the energy of the photon. Energy of one photon is h nu. So nu is given to us. Let's multiply 6.626 into 10 to the power minus 34 into 4.67, given as 4.67 into 10 to the power 13 per second. Okay, so we have to find out total number of photons that we need. So total number of photons that we need will be total energy upon energy of one photon, correct? So that becomes total energy is 330 upon, and multiplication of this comes out to be 3.09 into 10 to the power minus 20 joules. Okay, so this will be 330 upon 3.09 into 10 to the power minus 20, or if I solve it, this should come out to be 1.065 into 10 to the power 22. So the value of n, that is number of photons that will be 1.065 into 10 to the power 20. Let's move to the next question. It says calculate the wavelength of photon associated with an energy of 1 electron volt. Okay, so 1 electron volt means energy is given to us as 1 electron volt. 1 electron volt means 1 into 1.6 into 10 to the power minus 19 joule. And we have to find the wavelength. Okay, so we know E is equal to hc upon lambda, whereby lambda becomes equal to hc upon E. And we know the value of h into c also. Okay, so we can directly write it as 1.988 into 10 to the power minus 25 upon 1.6 into 10 to the power minus 19 joules, this much. So this comes out to be how much? 19, this is 12 point, we taking it as 12.4, this becomes 12.42 into 10 to the power minus 7 meter. This will be the wavelength of the photon. Okay, if they ask you the same thing in centimeter also, then you can also write it as 12.42 into 10 to the power minus 5 centimeter. Let's take up the next question. It says it takes approximately 1 erg of energy for a fly to lift off from the tabletop. Okay, how many flies could get airborne by Avogadro number of photon of yellow sodium light of, this should be the wavelength, sodium light of wavelength this much. Okay, so one fly is taking energy approximately equal to 1 erg of energy, correct? E is given to you as 1 erg. We know energy is hc upon lambda. Can we find the energy of one photon of wavelength 5800 Armstrong? So that will be equal to, energy of one photon will be, we know this is 1.988 into 10 to the power minus 25 upon, what is the wavelength given? 5800 Armstrong. So into 10 to the power minus 10. If you solve this, this comes out to be 0.0033427 into 10 to the power minus 16. Correct? And if we convert it, because energy was given in terms of ergs, so if we convert it in terms of ergs, simply multiply, these many joules are there, so multiply it by 10 to the power 7, so that will become, let's multiply 10 to the power 7, so this becomes 0.0033427 into 10 to the power minus 9 erg, or you can also write it as 3.427 into 10 to the power minus 12. Now it is asking that how many fly. Okay, it's asking, basically asking you the value of uh, how many flies could get airborne by Avogadro number of photons. Okay, so energy of Avogadro number of photons will be how much? Let's find that out. Simply multiply. This is energy of one photon. Then multiply it by Avogadro number. So energy of Avogadro number of photons will be 3.427 into 10 to the power minus 12 into 6.023 into 10 to the power 23. इसको solve करें तो ये आएगा 20.64 into 10 to the power 11 erg. और appropriately लिखें इसको तो ये हो जाएगा 2.064 इंटू 10⁻12। और क्वेश्चन में हमसे पूछा था how many flies could get airborne by Avogadro number of photons. Okay, so one erg corresponds to one fly. So 2.064 into 10 to the power 4 erg corresponds to 2.064 into 10 to the power 12 flies. Let's come to question number 9. It says a photon of light of wavelength 6000 Armstrong has energy E. Calculate the wavelength of photon of light which has energy equal to 4E. Okay, we know energy is inversely proportional to wavelength. E is equal to hc upon lambda. From there we know. Okay, so for the first one, for it is given as lambda is given as 6000 Armstrong. Means we can write E upon 4E should be equal to lambda 2 upon lambda 1, and lambda 1 is given to us as 6000 Armstrong. So just write the relation E upon 4E equal to lambda 2 upon 6000. That becomes lambda 2 equal to 6000 by 4, which is equal to 1500 Armstrong. Right? Come to question number 10. It says how many photons of frequency 2.45 into 10 to the power 9 per second are required to raise the temperature of 225 gram of water from 24.5 degrees Celsius to 99.5 degrees Celsius. Okay, now this is a pretty good question. Let's see. तो सबसे पहले तो we need to find out how much energy is required to bring about this change in temperature. Okay, so we know Q equal to ms delta T, where m is your mass of the substance, s is specific heat capacity, and delta T is the change in temperature. तो यहाँ पर mass is given to you as 225, specific heat capacity is 4.18, 4.18, मेरे ख्याल में कुछ मिसिंग है क्या? Only 4.18 जूल per gram per Kelvin. Okay, joule per gram per Kelvin. So they have given in terms, we have to take in terms of Kelvin. Let's convert the temperature also. So T1 is 24.5 degrees Celsius. That means 273 plus 24.5, ये आ जाएगा आपका 297.5. और second temperature also, that is 273 plus 99.5, ये हो जाएगा 372.5, and difference in temperature delta T will be into 372.5 minus 297.5, these many Kelvin. Okay, so this becomes 225 into 4.18. This difference comes out to be 75. Right, now it is asking how many photons of frequency this much are required to raise this temperature. We got the value of E. These many joules of energy we are requiring. Okay, let's calculate the energy of one photon also. So that will be equal to h nu, because frequency is given to us. Let's find it out. 6.626 into 10 to the power minus 34 into 2.45 into 10 to the power 9. ये सॉल्व करें या अभी रहने देते हैं. Let's solve it in the next step. So number of photons needed will be number of photons needed, मतलब total energy that we found out that was required to for the change in temperature, that is Q upon energy of one photon. Q कितना था? 225 into 4.18 into 75 upon, this is 6.626 into 10 to the power minus 34 into 2.45 into 10 to the power 9. इसे सॉल्व करते हैं, देखते हैं कितने टाइम्स जा रहा है. अप्रोक्सीमेटली 2 और ये this come out to be 4.258 into 10 to the power 28. These many photons should be needed for this change. Let's take up question number 11. It says a beam of electron accelerated with 4.64 volt is passed through a tube containing mercury vapors. As a result of absorption, electronic changes occurred with mercury atoms and light was emitted. Okay. If the full energy of single electron was converted into light, what was the wave number of emitted light? So here what is given to us is that we are applying a potential difference of 4.64 volt. Correct. Now let's calculate first the energy of one electron. So what will be the energy of one electron? That is E into the potential that we are applying, E into V. So that comes out to be 1.6 into 10 to the power minus 19 into 4.64. Okay, and we have to find the wave number. So we know wave number is what? Wave number is 1 upon lambda, 1 upon wavelength. So let's directly find 1 upon lambda in the question. We know E is equal to hc upon lambda. Just take 1 upon lambda, that will be equal to E upon hc, and we know E is 1 upon 1.6 into 10 to the power minus 19 into 4.64 whole upon h into c. So h into c value directly we can write 1.988 into 10 to the power minus 25. If you solve this, you get it as 3.74 into 10 to the power 6 per meter. If you convert it into centimeter per centimeter, then it should be 3.74 into 10 to the power 4 per centimeter. This should be the answer. Let's see question number 12. Vapors of mercury absorb some electrons accelerated by a potential difference of 4.5 volt, as a result of which light is emitted. If full energy of single incident electron is supposed to be converted into emitted light, okay, by mercury atom, find the wave number. Again it is asking for wave number, and we know wave number is 1 upon lambda. Let's see, we are applying a potential difference of 4.5 volt. This is almost same to the above question. So E will be equal to E into V, that we know 1.6 into 10 to the power minus 19 into 4.5. Correct? And 1 upon lambda will be equal to E upon Hc. That comes out to be 1.6 into 10 to the power minus 19 into 4.5 upon 1.988 into 10 to the power minus 25. इसको अगर हम सॉल्व करें तो this should give us the wave number as 3.625 into 10 to the power 6 per meter. Okay, और अगर सेंटीमीटर में निकालना हो तो आप वो भी कर सकते हो। वो हो जाएगा 3.625 इन 625 into 10 to the power 4 per centimeter. Right. Let's move to question number 13. It says the minimum energy required to overcome the attractive forces between and नहीं होना चाहिए था between electron and the surface of silver metal is this much. What will be the maximum kinetic energy of the electrons ejected out of silver which is being exposed to UV light of wavelength 360 Armstrong? Okay. तो सबसे पहले this is basically photoelectric effect. Okay, so let's find the energy of the photon. So E is equal to hc upon lambda, and this will be equal to 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 meter per second upon lambda is given to us as 360 into 10 to the power minus 10 meter. So if you solve this, this comes out to be 5.52 into 10 to the power minus 18 joule. This much energy. अच्छा, here it is given in terms of 10 to the power minus 19, तो इसको भी convert कर लेते हैं. This will be 55.2 into 10 to the power minus 19 joule. Now it's asking us what is the maximum kinetic energy, and we know that kinetic energy will be equal to energy minus the threshold energy. Threshold energy is already given to us as 5.52 into 10 to the power minus 19. So that becomes the maximum kinetic energy. Ke max will be 55.2 into 10 to the power minus 19 minus how much? 5.52 into 10 to the power minus 19. ये हो गया 55.2 minus 5.52, that becomes 8, 6, 9, 4. Okay, so that is 49.68 into 10 to the power minus 19 joule. This should be the kinetic energy. The last one, that is question number 14. Let's go through this question also. It says that calculate the number of photons emitted in 10 hours by a 60-watt sodium lamp, and the wavelength of the photon is given to us. Okay, so again the same thing. Let's find out the energy of one photon. So E will be equal to hc upon lambda, and that is 1.988 into 10 to the power minus 25 joule meter upon lambda is how much? 5893 into 10 to the power minus 10 meter. Okay, so this will come out to be 3.37 into 10 to the power minus 19 joule. Now let's find out the total energy emitted by this lamp. So the total energy will be how many? It's working for 10 hours. 10 hours means how many seconds? So 10 hours will be equal to let's convert it into seconds. कितना हो जाएगा? 36000 second. Correct? So total energy E total will be how much? The power, what is the power given? 60 watt. So power into time, that is 60 into 36000. This comes out to be 216, and how many zeros? 1, 2, 3, 4. These many joule. Okay. So the question was asking us calculate the number of photons emitted. Okay, we know the energy of one photon and we know the total energy. So number of photons emitted will be equal to E total upon the energy of one photon, that is 2161234 upon 3.37 into 10 to the power minus 19। इसको अगर हम सॉल्व करें तो ये आएगा 6.41 into 10 to the power 24। These many photons should be the answer.